Hey there, hi there, ho there. Welcome back and welcome to Unit 5, Minerals and Rocks. So we're just going to take this unit to briefly talk about minerals and rocks. For Geology 110, this class, a, a deeper understanding of all the different minerals and rocks are not absolutely necessary. This is something we get into pretty heavily with my other class, Geology 101. And we spend a week on minerals, a week on each of the three different types of rocks. So we spend a month on this. This class, we'll just spend a week, some of the basics, just so it can help us understand a little bit about how to infer information about natural hazards and disasters. So, minerals and rocks is the name of the game. Let's start off with the first one, shall we? Let's start off with minerals. Minerals are the building blocks of Earth. They're the most kind of basic item that we look at in geology. You know, if we're looking at the most basic stuff on Earth, we're talking about elements. Well, elements make up minerals. Minerals make up rocks. So elements, you know, that's kind of more chemistry. We'll touch on it a little bit. Elements, molecules, those sorts of things. But typically the smallest kind of thing we really focus on is minerals. So what is a mineral? They are, again, the building blocks of rocks. We define minerals as something that's naturally occurring, inorganic, meaning it's not part of a living process. It's got to be solid. It has to have a crystalline kind of molecular structure to it, and have a fixed chemical composition, meaning a certain mineral is always going to be made up of the same elements. It's going to have the same chemical formula. Of those, if it's natural or solid, you know, those are things that we can see. Inorganic, you know, if we're looking at, for instance, like a bone, well, that's an organic substance. That it would not be defined a mineral because bones are made by a living process. So when we're looking at something, there's a couple of things we can kind of tell right away whether it's a mineral or not. If it's natural versus man-made, if it's solid, if it's inorganic. The other things, having a crystalline atomic structure or molecular structure and a fixed chemical composition, that's something we can't see. We just have to know a little bit more something about the mineral itself, or have some fancy equipment or some high degree of knowledge of geochemistry to be able to do that. But we can look at things and see, oh, that's solid. Oh, that looks natural. Oh, that doesn't look like something from a living organism. So again, what this definition then does, it excludes man-made and organic substances. All right. So each mineral is unique. So like all substances, minerals are composed of elements and compounds and molecules. Elements are the basic building blocks of everything around us. So if we look at the periodic table of elements, this is what I'm talking about when I say elements. Something, you know, maybe you've seen in chemistry or other science classes. We won't get too much into the differences between elements and why they're here in the periodic table and blah, 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 blah. But just like everything in this universe, if we take different elements and you combine them together, they'll make different minerals. So elements themselves can either be found in just their pure form. So just, for instance, gold, Au, just a big lump of gold is a bunch of Au, a bunch of gold atoms mushed together, or chemically combined with other elements to make compounds, where a compound is two or more elements joined together. So just like elements, minerals can either be made of just one thing. Gold is a mineral, so it could be made of just gold. So a big chunk of gold is just made up of one element. Or if we look at, I don't know, something like salt, table salt. Salt is a mineral halite. It's made up of a combination of one sodium atom and one chlorine atom, kind of together, that compound. So minerals can either be a single element, or they can also be, more likely, made up of compounds. When we're looking at the Earth's crust is kind of heavy in about 12 elements, and then all that other stuff you saw on the periodic table it makes up a very small fraction of the crust. So all of these 118 plus elements, the Earth's crust is really only made up of 12 of them. All the other 106 of them make up a small fraction of the Earth's crust. Now, that differs as we go down in the mantle, the outer core, and inner core, but let's just focus on the Earth's crust, because that's where we are and that's where we find minerals and rocks. So in the Earth's crust, over 45% of the Earth's crust is made up of oxygen atoms. Not oxygen the gas, just oxygen atoms. Somehow they're combined with other things, other elements to form compounds, to form different minerals, to form different rocks. Oxygen gas, like in the atmosphere, that's O2. That's two oxygen atoms combined. What I'm talking about here is just oxygen atoms in any number combined with other stuff to form minerals and rocks. And so of the crust, 45% of all the stuff in the Earth's crust is oxygen. Oxygen is very well embedded in the minerals and rocks of the Earth's surface. Coming in second place, just a shy over 27%, is silicon. Again, typically not on its own, combined with other things in the crust, other elements in the crust to form different compounds, which form different minerals, which form different rocks. Then you also have things like, in third place, aluminum, fourth place, iron, calcium, magnesium, sodium, potassium, titanium, hydrogen, manganese, phosphorus, and then everything else. All the other 106 of them only make up 0.77% of the Earth's crust. So, since these kind of 12 things make up most of the Earth's crust, very heavily with oxygen, silicon, aluminum, iron, calcium, magnesium, and sodium, and potassium, got thrown there too. So these 1, 2, 3, 4, 5, 6, 7, 8, these 8 make such a big chunk of all the elements in the Earth's crust. Most minerals, and thus most rocks, are made up of this stuff: oxygen, silicon, aluminum, iron, calcium, magnesium, sodium, potassium. Maybe not all at the same time, but there's some of these in a lot of minerals. Let's take a look. So here are some somewhat common minerals. So garnet. This is a garnet. Can be a gemstone. I forget if it's a birthstone. I believe it is. But garnet is a mineral. You can see it's made up of iron, magnesium, calcium, one of those, plus aluminum, silicon, and oxygen. All of those things right here. All right. Olivine, this kind of cool greenish mineral. It's either made of magnesium and iron, and then silicon and oxygen. So you can see how this oxygen comes into play. It's nothing gas about it. It's just when you combine different elements with other elements, sometimes they give you gas, sometimes they give you liquid, sometimes they give you a solid. Muscovite, again, oxygen, silicon, aluminum, potassium, a little bit of hydrogen thrown in there. Quartz, this is just silicon and oxygen, made up of the two most common elements in the Earth's crust. So quartz is kind of a subset of minerals called silicates or silica, which are all made up of, in some way, shape, or form, have silicon and oxygen embedded in their chemical formulas. So since quartz is made up of the most common stuff in the Earth's crust, there's no guess as to why it's also the most common mineral in the Earth's crust. Plus, it's the most common mineral that makes up rocks as well. So quartz is the most common mineral in the Earth's crust because it's made up of the most common stuff in the Earth's crust. So it comes in cool crystal forms like that. It comes in kind of just milky white, lumpy forms, kind of a rose pink. It comes in purple. It comes in any number of different colors. Hematite, oxygen, some iron, Fe is iron. Calcite, calcium, oxygen, and this Cl by itself is carbon. It's the first time carbon kind of shows up. Pyrite, sometimes known as fool's gold, so we have iron, but then sulfur, kind of one of those rare ones we don't see too often. And then something like diamond. Diamond is mineral. Diamond is mineral. It's natural. It's inorganic. It's a solid. Has a set crystalline structure at the atomic level, and it has a set chemical formula. It's just C. That's it. It's just carbon. It's all oxygen is just carbon. And remember, carbon was not on the list of the kind of 12 most common elements in the Earth's crust. So carbon is kind of rare in the Earth's crust. Therefore, diamonds are rare. See how that works out? That's why they're so expensive. Before we get out of here, let me give you a part of the super secret code. It is the number 1. You got me? The number 1. One more time. The number 1. So we'll pause here. It was just, again, a very brief introduction to what minerals are. And we're going to talk about the different characteristics, how we can identify these different minerals. So looking back at some of these, diamond and pyrite and calcite, hematite, quartz, muscovite, olivine, garnet, there are different characteristics that if I'm looking at it, I can tell this is different from this. There are some obvious ones, and there are sometimes some less obvious ones. So yeah. That's what we're going to look at. When we come back, we'll look at mineral characteristics. I'll see you back here in just a second.